can you actually run on a liquid? We're about to find out in the massive Oobleck Non-Newtonian challenge. We built a massive custom pool and mixed thousands of pounds of cornstarch and water to create a huge pool of Oobleck. The goal: sprint across the surface before the physics drags us down. This isn't your average kitchen science experiment. We're talking about a custom-built pool filled with a massive volume of cornstarch and water. The stakes are high and the sludge is deep. Oobleck is a non-Newtonian fluid, specifically a shear thickening one. That means it acts like a liquid when relaxed, but solidifies under sudden force, like sprinting across it. Before the main event, we did a small-scale test to prove the concept. A simple bowl of Oobleck shows how a slow pour is liquid, but a quick punch is solid. Creating the massive pool of Oobleck was a challenge in itself. It was messy, chaotic, and physically demanding. We mixed hundreds of gallons of water with tons of cornstarch in a chaotic, time-lapsed process. Getting that perfect consistency was an unexpected hurdle. Achieving the right balance was critical. Too much water, and it would just be muddy. Too much cornstarch, and it would be impossible to mix. We aimed for the sweet spot. To verify the pool was ready, we tested the surface tension by dropping heavy objects. If it was the right consistency, the objects would briefly stay on top before sinking. The moment of truth had arrived. It was time for the first high-speed sprint attempt. Success or catastrophic failure, we were ready. We took a deep breath and launched the first runner across the Oobleck pool, capturing the immediate reaction to the force resisting their movement. Using slow-motion footage, we analyzed every step to understand exactly why the fluid behaved the way it did. The science was unfolding before our eyes. The thrill of running quickly transitioned to the comedic reality of getting stuck and slowly sinking into the viscous sludge. Getting out proved to be a challenge. We wanted to know how far we could push the physics. Was speed alone enough, or would added challenges defeat the Oobleck runners? Next, we introduced obstacles and increased the distance. We needed to test if maintaining momentum over a greater area would be enough to conquer the pool. We brought in a physicist to briefly explain how human body weight limits the Oobleck's resistance and the specific conditions needed for the shear thickening effect to work. We filmed a hilarious fail montage of different techniques: jumping, skipping, crawling, and analyzed why they simply did not work against the physics of the Oobleck. The fun had to end, and with it came the ultimate challenge: safely and efficiently disposing of thousands of gallons of non-Newtonian fluid. The massive volume meant careful, safe disposal was essential. This was perhaps the hardest part of the entire experiment. We conducted one final test, trying to pump or move the Oobleck when it was solid versus when it was liquid, highlighting the material's wildly contrasting properties. What an experience! The Oobleck challenge was a massive success. Stay tuned for our next chaotic experiment. You won't want to miss what we try next.